GAC, it's Coach Jay. Hope you're having a fantastic day today. We're going to get started on section 3.2, logarithm functions and their graphs. And I forgot to podcast this in class, so shame on me. But regardless, we're going to get started here with some Q&A, going through some stuff for the next about 10 minutes here, all right? All right, here we go. All right, first thing we want to look at is, remember when we're talking about a log, we have this thing that is y equals log base. Sorry about that. Let me get to here. We have this thing where it's y equals log base a of x. And we remember that in this context that we can actually simplify this by changing it to exponential form. We do this by taking a and shooting it to the left-hand side, making it now a. Again, the base of the log, in this case it's a, is the same as the base of the exponential. So we would say that this is x, and then once we shoot the a over, we drop the log. We say a to the y equals x, okay? A to the y equals x. And we would say that these two are of the same value. One of the keys, though, to remember is this is a little different than our exponential equation, because remember our exponential was y equals a to the x power, right? And we remember that in this context, this looks like it's the same, but actually x and y are, they're flip-flopped, aren't they? And so because of that, we call these inverses of one another, that the exponential, in this case, would be the y equals a to the x, and x equals a to the y, are inverses of each other because x and y are flip-flopped. Now, a couple things to note. We have actually 4 different properties to kind of note here. We remember that no matter the base could be a or whatever it needs to be there. If the outside value following the log base a is 1, we will always produce a value of 0. Same holds true. Number 2, if the base of the value is same as the value itself of a, then we would cancel this out, producing us a value of 1. So let's say that I had the log of log base 3 of 3. In this context, I could cancel because they're the same and allow this to be an answer of 1. Okay. Same holds true. Number 3 is very similar, except when I cancel, I have an x value left over to where I would just get, this would cancel to give me a value of x. Same thing with this right side here, except now notice that the log base a of x is an exponent, to where the base of the exponent is the same as the base of the log, which I could cancel, producing me also a value of x. The only other one to remember is that if I have 2 logs here, like this and this, and they have the same log and then base here, we are able to cancel what I do to one side I could do to the other, as long as there's only 1 log on each side, to where then I produce an expression of x equals y. One other thing to remember is if, let's say, I have the log of 100 here, and it doesn't have a base, the base is always understood to be 10. So if there is no base there, it is understood to be a value of 10. All right, let's look at a couple of ones here. Let's say number 1, we were trying to convert that to exponential form. We would take the 4 and shoot it to the other side, dropping the log, making it 64 equals, and when I shoot the 4 over, it now becomes the base of my exponential, and then we put that value that was on the right side as the exponent. So that also goes up as the exponent there. So 64 equals 4 to the third. Another way to remember this too is if I did something like number 7, ln of 1 equals 0. The base of a natural log is actually the value of e. So instead of having a base of 10, this time it has a base of e. When shot to the other side, again the 0 comes up, is the same as 1 equals e to the 0 power. Okay? So just again a heads up on how I would attack that. Now if I go backwards, like 5 to the third equals 25, and I say convert this to log form, I shoot the 5 to the right hand side, giving 3 all alone by itself, all that lonesome over there, that 3, and it would be equal to log base 5, and then 125 goes on the outside. just like this. So log base 5 of 125, and then 3 stays on the left. Let's look at one like 13. 13 is another good example. 6 is the base, so it gets shot over to the right side, leaving me negative 2 on the left, equals log, whatever gets shot over goes as my base, so log base 6 of 1 over 36. So that would be the same thing as number 13 there, okay? Another one to kind of remember too is one like number 18. Number 18 says log base 16, and really this is equal to y, right? Because g of x is the same as y, or f of x is the same as y. It's a function. So log base 16 of x, x is 1/4, so we'll put 1/4 out here, okay? Now to simplify this, we like to change this to exponential. So we shoot 16 to the other side, making it 16 to the y power is equal to, and once I shoot 16 over, that log drops, and it equals 1/4. Now, the question becomes, what can I do to get this to where it's 1-to-1, where the bases are now the same? Well, to make it a little easier, I could change 16 to 4 to the 2nd power. Keep that y on the outside like this. There you are. And that equals 1/4 could be the same as 4 to the negative 1st. Okay? And so once I get that there, again, an exponent to an exponent, we can multiply, making it 4 to the 2y. And so the 4's cancel, giving me 2y is equal to negative 1. Well, you know what to do now. We divide by 2, producing a value of negative 1/2. Okay? And that's how you would attack that there. 20 would be log base 10 of 10. So if 10 gets plugged in here, since they're the same, they could cancel, giving me a value of simply 1. So just again, a heads up. These are also on your homework, 25 to 30. Remember that if the log base 7 is the same on both sides and there's only one of them on either side, we could cancel, giving me x equals 9. Over here, we could cancel log base 6 of 6, making it 2 equal to x. On 29, we could cancel the log base 8s on both sides, getting me x equals 10 to the negative 1st, or 1/10. 26 cancels to get me a value of 1 equals x, and so on and so forth. Those are how you would attack that there. All right, with this one, we did this in class just a little bit, where we were trying to attack 36. And the question with 36 was, how would I graph this? Well, with y equals log base 6 of x, we can't graph this. We can't suppose to graph this. So we want to help by getting this 6 to where we throw it to the other side and get it to exponential form. So instead, we have 6 to the y power is equal to a value of x. So now we can go in with our x and y values, where we're going to plug in values for y and get out values for x this time, mainly because it's the inverse, and now it's, instead of being equal to y, now it's equal to x. So we can just kind of reverse these to where it's negative 1, 0, and 1. 6 to the negative 1st would be 1/6. 6 to the 0 power is 1, and 6 to the 1st is 6. So when we graph this, we get 6, 1. We get 1, 0, or 0, 1, or yeah, 1, 0, my fault. Make sure you read it from x and y, and 1, 6, comma, negative 1. So this graph will look something like this here, and this will keep going downward to where without any transformations, it has a vertical asymptote at x equals 0. Note also the domain. The domain would be from 0, in parentheses, comma, to infinity. You could also say that the domain is x is greater than 0. You could say that too for our domain as well. X-intercepts, remember x-intercepts is when 0 is y, right? So when 0 equals y, what is my x value? So we could always, again, plug 0 in for y. 6 to the 0 is 1, and so my x-intercept's 1, comma, 0. We got that there. Now, the question becomes, what if I were to transform this by taking, let's say, number 40 and changing that up a little bit to where now our values become different? Well, Now we're going to do y equals negative log base 6 of x. Note that this x plus 2 will push this to the left 2, okay? So we're going to make a little different t-chart here, x and y. So we'll put negative 1 in, 0, and 1 in. Okay, so before I do anything, I want to make sure I change the sign from positive to a negative here, shooting the 6 to the other side to get 6 to the negative y is equal to x. So it's going to look a little different because when I plug negative 1 in, it'd be 6 to the first, which is 6. Plug 0 in, we'd still get 1. And when we plug in 1, it'd be 6 to the negative first, which is 1/6. So we have 1/6, comma 1, 1, 0, and we have 6, comma negative 1 right here. Okay. So we still have an asymptote of x equals 0, but because the negative was on the outside, because it was out here, it reflects up and down. But if it was on the inside, such as number 38, what was right would now be reflected left if we had something like that. Okay, so it would look something like this. But I do the negative in the graph first, and then once I transform it, because I have to push it to the right too, or left too, my fault, I will do that by going left 2, even the asymptote. Again, when we push this left, everything goes left 2. So I'm going to put a little different asymptote. So this is going to go left 2, left 2. Okay, so the actual graph should look something, it should be this yellow one. No, it's a little off, but you see the idea. So what was in orange, which was a basic graph like number 36, I transformed by first reflecting over the x-axis. And I did that here, okay, right there. And then once I did that, I transformed it to the left too based upon what was inside. Remember, if it's on the outside like this, it would push it up and down, but it would not impact my vertical asymptote that's there, okay? Again, you could kind of look and see, like for instance on 51, what is the transformation there? Well, this is going to be a vertical shift up 4, and this would be this negative reflects it over the x-axis. Okay, so it'll go up 4 and reflected over the x-axis to where it will look like this, like we just showed earlier. Okay, all right, awesome, good stuff. Okay, hopefully that helps you, and we'll look at some of this other stuff later on. Many of these are the same thing. So as we do this, the big thing to remember is that if there is no base of an ln function, that we would actually have e on the bottom, which would allow us to cancel and rock and roll from there, okay? Hopefully that helps you. Hope you have a good day, and we'll go from there. See y'all. Bye.